the first two examples, I give you an ordered pair, and I'm asking, there should be a question mark, is the following a solution to the system of inequalities? So just like we had the ordered triple last lesson, and we had to store the values for x, y, and z, plug them in, see if it was true, that's essentially the same stuff. You're just back to an x and a y. However, you don't have an equals, it's an inequality. So once you plug those values in and you get your numbers, you're going to have to see if the comparison is true, not are they equal. Okay? So I'm going to take my 0, 0, and I'm going to take that for x and y. But if I look at my inequalities, I really don't need to store it for y because y is already by itself on the left. So all of these are going to already be 0, and then my inequality, because of the way it's set up, it's already in y equals mx plus b form. So I'm really only going to store 0 for x. And then I'm going to type the right side of my inequality. So 2x plus 3, that gives me 3. So I need to read it and see if it makes sense. Is 0 less than or equal to 3? Don't get hung up on the equal to. So look at the 0 is less than 3. Is that true? Yes, so it's true for the first one. I move on to the second one, and I'm going to have 4x minus 2. That's going to give me negative 2. Is 0 greater than negative 2? Yeah, so it's true for the second one. And I'm going to type x minus 2. I get negative 2 again. So is 0 less than negative 2? No, it's not true. So the moment it's not true for one of them, it's not a solution. Okay? So it's not a solution because why? You can tell me because 0 is not less than negative 2. You can tell me it is not true for all three inequalities. You could tell me it doesn't satisfy the third inequality. You could tell me different things. Just make sure you have some type of reason there. Okay, so I'm going to be looking for this and your reason. And obviously the answer, as in not a solution or is a solution. Okay, I'm just not writing it out right now. Because I think that y'all are good with plugging this in, right? So we're going to skip example 2 because I think we're fine. If it's true for all of them, your answer is yes, it's a solution. Okay? So if we move on, we're still going to need to get it in y equals mx plus b if it's linear. You're just going to now have an inequality instead of an equal sign. Okay? Because it's an inequality, we're going to have to check and make sure our lines are correct as far as dash versus solid, and we're going to have to do shading. So if you remember from Algebra 1, if you have less than or equal to, you shade below your boundary line. If you have greater than or equal to, you're going to shade above. Okay? Now, if it's just less than or greater than, you have a dashed line. If it's equal to, you have a solid line. So whenever I would teach it in Algebra 1, I would always say, if you have a solid line in your inequality symbol, it's a solid line on your graph. Other than that, it's dashed. Okay? So that might help keep it straight in your head too if you don't remember your rules. If you have a solid line somewhere in your inequality, it's solid on your graph. Okay? So if you have absolute value inequalities, you're going to have to do the t-charts again, and then we also do a test point for absolute values. We don't do test points for linear because we go with shade above, shade below, but with absolute value, you've got two parts of it, it's different, and we're going to use test point. Okay? So for the first example, we've got y is greater than negative 2x minus 5. That's in the form I need it. My slope is negative 2, and my y-intercept is negative 5. So I'm going to plot my negative 5 on the y-axis, and I'm going to go down to the right one. And then I'm going to look, is it going to be dashed or solid? If I look at my inequality symbol, it should be dashed because it's not equal to. If you're doing it in a colored pen and you do solid instead of dashed, just make a little side note with an arrow and tell me this should be dashed. Now, on some lines, some people have trouble figuring out where's above and where's below because on the really steep slopes, it kind of looks like left and right instead of above and below. So if you have trouble with that, you can put your pen or pencil on your y-intercept, and if it's greater than, you go up, and that's going to be the section that I shade. Okay, if it's less than, I would go down, and that would be the section that I shade. So if you struggle, always put your pen or pencil on the y-intercept and go up or down according to your inequality. So it's greater than, I'm going to go up. I'm going to lightly shade this section. The reason I'm doing it lightly is because I'm looking at where it overlaps. If it overlaps and you're too dark and you can't graph the second equation and really see what you're doing, that's going to be an issue. And if I can't really see your second line because you shaded too dark, then I'm going to have problems grading it. So make sure that you can easily tell what you're doing. Now I do my second inequality in a second color so I can see that. I've got x plus 3, so my slope is 1, my y-intercept is 3. So I plot my 3 on the y-axis and go up 1 over 1. Now it's equal to, so that's going to be a solid line. And my inequality is less than, so I would shade below that line. Now my solution area is the overlap shaded region. So I'm going to go back in and I'm going to make that overlapped region the darkest so that it indicates this entire area is my solution. Meaning any point that falls in that darkest region would be a solution and would satisfy both of those equations. So I no longer have one specific point. I now have multiple points in that entire area. Y'all good with that? So if I look at example 2, I've got my absolute value inequality. So I'm still going to do my table with my vertex. What's my vertex going to be if it's just the absolute value of x plus 4? You do the opposite sign. So negative 4. I don't have anything added or subtracted, so it's just a 0. And then I'm going to do 2 above and 2 below. Now this is a simple just x plus 4, so I'm not going to store the values. I'm just going to do it. I'm going to talk it out. I'm going to have negative 6 plus 4, which is going to give me a negative 2. And the absolute value of negative 2 is positive 2. Then I'm going to do the same thing with negative 5. I take negative 5 plus 4, it's going to give me a negative 1. The absolute value of negative 1 is 1. Then I'm going to take negative 3 plus 4, gives me 1. The absolute value of 1 is 1. Negative 2 plus 4 gives me a positive 2. Absolute value of positive 2 is 2. Okay, so I'm going to plot those points. I'm going to look back at my inequality. Is it going to be a dashed or solid graph? It's dashed. So here we're going to do a test point, okay? Our test point is going to just satisfy whether it's going to be true or not true. So if it's true, we shade where the test point is. If it's not true, we don't shade where the test point is. If at all possible, I choose 0, 0 for my test point because that makes it easy with my x and my y's. The only time I don't use 0, 0 is if the graph is on 0, 0, as in one of the lines, like one of these sides, are going through 0, 0. It's the only time I don't use it. So what I'm doing is I'm taking this for my x and my y and I'm plugging it into my equation. So I've got 0 is greater than the absolute value of 0 plus 4, which is just 0 is greater than 4. Is that true? No, that's not true. So if the shaded region is my solution, but this test point is not true, then I'm not going to shade where that test point is. You understand that? So I'm going to shade the opposite region, which is going to be right here. If it were true, I would shade every part of that region that had the test point. So way back when, that is really how you figure out where to shade. It's not a shade above, shade below. It's really, you should be doing a test point for every single inequality to figure out where you shade. But we have the tricks to go above and below for linear. Okay? Now, if I look at y is less than or equal to 3, that's just a horizontal line. It's equal to, so it's a solid horizontal line. And here it's less than, so I shade below. So my solution region is really that small little triangle that is formed. Are good with that? Okay, so if I look at example 3, I've got y is greater than 2/3 x plus 2. It's in the form I need, which is my slope of 2/3 and my y-intercept of 2. So I go up 2 to the right 3. Is it going to be dashed or solid? If I look at my inequality, is it dashed or solid? It's going to be dashed. And greater than is shaded above. And then y is less than or equal to 2/3 x minus 1. My slope is 2/3. My y-intercept is -1. Now this one is going to be solid because it's equal to. And it's less than, so I'm going to shade below. So for this case, do I have an overlap shaded region? No. So if I do not overlap whatever is there, my answer is no solution. Not every parallel inequality will be no solution. I could have had them overlap in this middle area, but if there's no overlapping for all of it, then you're going to have no solution. Okay, now if we look at example 4, I've got x is less than or equal to 2. That's going to be a vertical line, and it's going to be solid because it's equal to. Now if I have a vertical line, it cuts my grid into left and right. There's no longer above and below. So for vertical lines, if it's less than, it's pointing to the left, you're shading left, less than left, okay? If it's greater than, you're shading to the right, your numbers are getting larger. Then I've got y is less than or equal to -1. That is a solid horizontal line passing through -1. Less than means I'm shading below. Then I have a -y for my last inequality. I need it to be just a y. So what do I need to do with this? Divide by -1. When I divide by -1, what also needs to happen? Your sign changes. So don't forget to flip that. It's now y is less than -2x minus 4. So your rule for flipping your inequality symbol whenever you divide by negative still applies. If you multiply or divide by negative, you still got to flip it. So now I'm going to have my y-intercept at -4. I'm going to go down 2 to the right one. And this one is going to be a dashed line because it's not equal to. Less than, so I shade below. So my overlap shaded region is going to be this area, but make sure you don't go past that vertical line. So you have to be very careful when you have more than 2 that you satisfy all those boundaries. Y'all good with that? Okay. We're not going to do all 3 of these. We're going to look at example 6. I think that y'all can graph inequalities and be fine with linear inequalities, right? Okay, so we're just going to look at example 6 and what happens here with your 3 equations. So if I take my 2x plus 3y is less than 6, I'm going to subtract my 2x. 3y is now less than -2x plus 6. Divide by 3. And y is less than -2/3 x plus 2. So I'm going to plot a point on 2. And I'm going to go down 2 to the right 3. And that will be a dashed line. It's less than, so I shade below. Then I have y is greater than or equal to -2/3 x plus 4. So here I've got my 4 for my y-intercept, and I'm still going down 2 to the right 3. This one is now solid. It's greater than, so I'm going to shade above. And then I take the negative 2x plus y is less than negative 2. I'm going to add 2x. Y is less than 2x minus 2. Plot my negative 2. And I go up 2 to the right one. And that one is not equal to, so it is also dashed. Less than, I'm shading below. So when I shade this one, do I have a region where all three overlap? Because these two parallel lines were shaded in opposite directions, I still have a section that was overlapped for 2 equations, but not all 3. So it has to be all 3. Since it's not, it's going to be no solution. I wanted y'all to see that happening. Even though it overlaps, it doesn't all overlap. Okay? Y'all good with that? Do we have any questions so far? Okay. We just have 2 more examples. I ran out of time yesterday, so we didn't do the word problem, so we're not going to do the word problem with y'all. We're just going to do these 2 examples. So now it's, I give you the graph of the inequalities, and you have to come up with the equations. So what we're going to do is we're going to number our lines. It doesn't matter how you number them. It just helps me associate which equation goes with which line. I typically go kind of like clockwise. Again, it doesn't matter though. It just helps me grade your paper a little bit easier. If you have a diagonal line, you're going to have to identify your slope and your y-intercept. So for equation 1, for that inequality, it's a diagonal line. I'm going to identify my y-intercept and figure out what's going on with my slope so that I can build it in y equals mx plus b form. Okay? So my y-intercept for this line is where? 1. And then if I'm looking at this line, what's happening with my slope? Where am I going? It's going down into the right one. So down 1, right 1, down 1, right 1. So my slope would be -1. Okay? So when I go and do my inequality, I know it's going to be y. I have to figure out what is my inequality. I'm going to look at this line and I'm going to look at the shaded region and see, is that shaded region really above or below my line? So for this one, the shaded region is above my line and it's a dashed line, so it's going to be just greater than. Okay, so it's going to be y is greater than. I'm going to do my slope, so -x plus my b, which is 1. Y'all good with that? Building that? So then example 2. Line 2 is a vertical line, so that's x. It's shaded to the left of my line, so it's going to be less than, and then it crosses through 4, so it's going to be x is less than 4. And then line 3 is a horizontal line, so I know it's going to be y. It's shaded above that line, so it's going to be greater than and also equal to because it's solid. And that crosses at 3. Y'all good with that? Okay. So then my next example, I chose the vertical line for number 1. Vertical line is x. It's shaded to the left, so it's going to be less than. It crosses 2, so x is less than 2. So then for 2 and 3, I need to identify slope and y-intercept. So my y-intercept for the line 2 passes through the origin, so that's just 0. And then what is my slope going to be? 1/2. I go up 1 to the right 2 to get to my next point. Up 1 to the right 2, so my slope would be 1/2. So I'm going to have y, it's shaded below that line, so it's going to be less than my 1/2 x. I do not have to put the plus 0. So then for 3, what's my y-intercept? My y-intercept is -2. My slope is now going down 1 to the right 2, so my slope is my -1/2. So I'm going to have y, it's shaded above that line, so that's going to be greater than -1/2 x minus 2. Okay? Y'all good with that? Do we have questions?